Hey, good afternoon. We have a great audience of the chair and one attendant. Thank you for coming, David. Okay, so I'm going to, this is already been recorded. Let's go with the show. Today, I want to dedicate this presentation in the memory of Annette Taylor and David Saul. They have done a lot for label research, and I was not able to find a picture of Annette. This is David, of course, and but I found the email when on February 8, 2015, she notified that we have been accepted to present at the ITPC. And I actually credit that as springboarding our our progress in terms of going to conferences and presenting our research. Today, as I told Michael, decided to do a blend of some presentations I've been doing recently. In fact, I was not expecting to present at the ITPC because I had a lot of conferences that did not have enough new material. But I was given the go-ahead with blending the presentations that I have been doing lately. The ITPC last year, the trends in functional programming in education, the trends in functional programming itself, those two were in Boston, where I'm now. And just 6 days ago, the ISEC 2023 in Maryland, I wasn't there. Very nice locations, the Applied Physics Lab. But as you see, a lot of these presentations are geared towards education, which is the main motif of the presentation today as well. And if time permits, I'm going to give a live demo of the product that it's kind of manifestation of the research we have been doing for many years now. So we're talking about education, in particular about programming education. And learning the syntax of programming languages, it's a well-recognized in research obstacles to learning. In fact, it's recognized for a long time, so much so that Scratch was invented 20 years ago and has been in use for 15 years. Am I speaking too loud, Dennis?
Everything's fine, Enzo, okay. Just fine.
Okay, let me know if the audio is not good. So Scratch has been in use for 15 years, was invented 20 years ago, if I remember correctly. And so of course comes from the MIT Media Lab. Here, the idea is that don't have to learn the syntax, you just have to make these blocks snap with each other. And that basically is by definition going to be a syntactically correct construct. More recently, a researcher from Leiden University, Feline Hermans, or Feline, I think it's pronounced, he has come with this idea of the gradual languages. Basically, the idea is, let's say something like Python and dumb down the syntax, in fact, making it in a way that is not completely general. Like imagine you can do a print and then write like a hello world without putting the quotes. And you say, oh my God, that's horrible, because then how you can, distinguishing between that and something else. The idea is that, well, we just print everything that is until the end of line. So it starts with a very lax syntax, which will not be usable, suitable for a programming language. And then from there on, it starts tightening up the syntax as students go up in the levels. Okay, it starts with very simple instructions and the ways to make it fun by making some command to make the computer ask you something and you can enter it and then it prints it down when you ask to print it. But by level 4, I believe, then they start introducing conditionals. In level 5, you start doing the repeat instructions. So now they are Turing complete because they have loops and conditionals. And by the time a student reaches level 7, then already knows a significant subset of Python. And the reason Feline did this is because Scratch has not been proven to generalize well. I mean, kids learn to use this, but then they still have trouble learning programming languages. This one, by design, is kind of suitable for generalizing. All right, enough about the approaches that are nothing to do with mine. The approach I'm proposing here is stop fearing the syntax, embrace the syntax. Embrace the syntax in a smart way, the way that is conducive to exploring the synergy with math. the natural synergy that we have between mathematics and computing. And I'm going back to a time I cannot remember, but I'm pretty sure that sometime in kindergarten, they showed me something like this. And I presume, and I'm not a cognitive psychologist of the evolutionary age, I'm not Piaget, but I presume that this must be mind-bending at first, because maybe by now you have seen the word cat next to cat, dog next to dog, you start learning the language, and now I see these strange symbols next to the animals, but how come the one is not consistent here? This is a dog, this is a cat. And so at some point, I mean, the mind creates this abstraction. What's common about this, the two? Okay, we see it clearly, but there was a process of abstraction going in our mind at that. Parenthesis, clearly we don't teach kids natural numbers using piano formalization. We use something into that. This is our first foray into programming in a way. It's syntax. We learn these symbols. This is syntax. But from there, well, you're quickly getting crazy around the waltzers. Okay, we learn the positional number system, addition tables, multiplication, etc. At some point, we start mixing addition, multiplication, writing expressions like this. Right? Notice, we learn about operator precedence in elementary school well before we see in programming languages ever. So the turtles keep piling up. Computer scientists like to think about this as levels of abstraction. It's turtles all the way down. And by the time we enter high school, as I discovered, a few months ago, actually doing the presentation, we already know a lot of syntax. I was thinking about, okay, when in high school, we learned this. And then I realized, I went to Italian high school. I actually saw all these formulae here in middle school, except two. The first one, famous Einstein, right? And the last one, about forces, gravity. And guess what? The only reason I didn't see this in middle school is because physics, it's in high school. But notationally speaking, there is nothing new here. So that I didn't have in the distance of 2 points in a Cartesian plane. There is nothing here with the square here up there that is not being seen already in trigonometry. We have learned all this syntax by the time we enter high school. So at this point, I ask, how much syntax do we really need to learn before we start computing, which I consider programming, first form of programming? Okay, and there might be some debate on that. We'll go into that in a moment. What if I told you? What if I told you? Students, they already know the syntax. That's the title of one paper that I presented, not published. How much syntax we really need to show down the throat of these poor students before they can start learning programming? How about we use the syntax of math? It's not exactly that. And you know this because some of you probably use LaTeX in a way. We need to linearize it. We cannot have the two a little bit up in the programming language, etc., etc. But that's a small change. Now, look at this. I actually cheated with this slide. In a way, cheated against me. The point I'm trying to make is that the syntax of arithmetic expression, it's remarkably similar, almost identical across programming languages. I started thinking, I'm going to take the top 10 programming languages in the IEEE website, only to realize, okay, SQL kind of doesn't apply. It's something, so you can do some math there too if you wanted to, but it's not designed for that. HTML, it's not in a technically speaking, my programming language there, but all the programming languages there were derived from C or similar. So I had to dig deep. I said, I wanna put diversity in this slide, diversity. So I put list, historically important, but not top 20. I put Haskell and the other ones, OCaml, which is a language I'm using. And notice, not by chance, because computing started with Fortran, basically, high-level languages. And by then, what we were doing, number crunching. And that's actually how I ended in the degree. I was a sociology and statistics student in Italy when I discovered Fortran. So like Dijkstra says, well, these are actually in a way the easiest kind of programming application you can do number crunching. Well, we're trying to teach programming. Why don't we start with easy and with something the students already know? Next. At this point, and I forgot the segue here, some will say, okay, sure, but those are just expressions. Okay, you can write them on a REPL, and you can compute them, but that's not really programming, is it? And here's where I defer to Simon Peyton-Jones, because this seminal paper here say much better than I can. I normally don't read slides, and this is one exception to the rule. It may seem odd to describe a spreadsheet as a programming language. Indeed, one of the great merits of spreadsheets is that users need not think of themselves as doing programming, let alone functional programming. Rather, they write formulae or build a model. However, one can imagine printing the cells of a spreadsheet in textual form like this. A1 equals 3, A2 equals A1 minus 32, A3 equals A2 times 5 nines, and then it plainly is a functional program. Now, there is something to say here, because some people say, why is this a functional program? Well, it's equations. And even if you see like think about this, like I'm assigning this to A1 and A2, this will be what I call in compiler constructor, single static assignment form, SSA form, which is actually a way to express functional computing, okay? So he's completely correct here. This is a functional program, okay? The style of languages like Lustre and others that actually have an equational kind of paradigm. It's functional. Now, he says spreadsheets as a programming language. I like that because, you know, it makes it easier to make my point. But actually, I am more subtle than that. Spreadsheets are the IDE, the integrated development environment for some programming language underneath. This one being the case of Excel. So they are a user interface, an environment to program in a functional language, because all spreadsheets are functional reactive. You change something, things recompute. So in reaction to the change, look, things recalculate. And I can see my own slides because the thing about, okay, saying here that to program with spreadsheets, all you need to know is the language of expressions, which I already proved it's there in all the programming languages. That right-hand side, like Baku say, the beautiful right-hand side word, right-hand side of the assignment, the word of expressions, that you compute them. Now, somebody says horrified that, gee, I don't really want my children to learn programming with spreadsheets. And I agree with you. I was horrified too. This is what motivated the research I've been doing for years. But the problem does not reside with the paradigm. The functional reactive paradigm is actually very elegant and good. There are three problems, or I should say where, because now things are starting to change. And I like to think, but I am not arguing that part of this is also due to our research. I mean, we have been poking the bear. Microsoft saw our research first in 2017. I'm aware of that. But these three problems were already known to Microsoft. In fact, the 2003 paper was dealing with this. Lack of functional abstraction, which means users, spreadsheet users, cannot define new functions. They have to use the one that are predefined. To which some advanced Excel users say, that's not true. I can write my formula, my functions in Visual Basic. Okay, but then you are going out of the spreadsheet core. The idea here, and the whole point also in the paper of Simon Peyton-Jones et al., is that it's programming with the core spreadsheet, what you can do in the beautiful word of formulae, as opposed to plopping a language that was not originally designed for that. And let me just mention one thing. I think this is the strongest argument I have for why Visual Basic is cheating. When you see again, the right-hand side of an assignment in Visual Basic, integrated cell, the right-hand side doesn't have the same language of the things you can put in the cells. The answer is no. The answer is no. And that's why it's cheating. You just plopped an imperative language. By the way, I don't take exception because it's imperative. One of the hardest things, but actually useful to do, is how you add effects to this in a way that is orderly, okay? So it started first with macros when people wanted to automate things, and then they realized, like always, macros have short legs. So they took Visual Basic and they plop it on top. And it's been very successful integration. I don't argue against that. But it's a dirty solution. It's a very dirty solution. And it shows. So in 2020, December, finally, Microsoft announced the addition of Lambda expressions to the core spreadsheet. Not only, and those were also recursive. So Excel, the Excel core for the first time became Turing complete because the if was already there from decades, right? It's there. But they did not have recursion. The recursion, you need to define the function that does recursion. Again, you do something worse, like a fixed point function there. I'm not going to go there. So the point is that we need the functional abstraction. It's like one of the things when I learned Fortran was the thing that made me enamor me programming, that you can program the function first and then reuse it. It's also an overly simplistic type system because you program in these worksheets, this amorphous grid of cells. And how you write the formula, you say, well, IA2 times B7, etc. What you're literally doing is you're programming inside of an array with formulae, and cells in an array refer to other cells in the same or another two-dimensional array. And it's a soup of A1 coordinates, and which some people say, oh, Enzo, but the aliases, believe me, the aliases have the same problems that have always had in history, okay? An alias for a thing is not the same thing as being able to define the real thing. Define your variable named interest rate usually consistently across that, which goes also to the issue of the separation of the model and visualization. Because the variable interest rate should exist independently of where it's visualized. But here's the problem, spreadsheets are very concrete, very intuitive, yes, but the worksheets are the primary element of visualization. That's what you see when you use a spreadsheet. You see the worksheet and you change the tabs, right? But they are also the repository, the custodians, if you want, of the formulae, of the computation model. So they serve two masters. They do two things. And as you know, it's always bad to entangle two things. We know about the model view controller like paradigm since the 90s, I believe. It's for a reason. It's good to separate the model from the visualization. Spreadsheets don't have that. And so all our research has been doing for over a decade is show that we can get rid of these issues without throwing the baby with the water, okay? Like keeping what's good about spreadsheets and getting rid of the bad, with one exception. We actually kept A1 notation for no other reason than to show that you can still have it, but it should be considered harmful. See, in 2017, ZenSheet was still present a paper on the workshop, and Monica Figuera earned her spot in a student research competition. So it was the first time that was actually published, not to be undone by my own research assistant. It took me many years. Right? In 2021, I finally get published peer review at the ICICT. And this is the paper. You see my name, Monica, Javier, etc. Pablo. There's people in Costa Rica, people in Spain, people in Germany, people in France, people in the USA, Joaquin, Manager, Jax Frankel. Lots of diversity here without anybody having to breathe down my neck about diversity, because this came out organically. Well, sorry for too much of the brag. This is the link to that presentation. Is actually, sorry, I have it here in the slides. And this is Javier here. I don't know if it's hidden by the. This is Javier here, who converted my interpreter to a compiler. Okay, who's almost 1.5 years of effort, and it's demonstrating precisely how we can use this even as a worksheet with A1 notation at all, which we don't like to do, but it's to show, hey, we don't only have real variables, we don't only have structs, we have arrays and composable arrays of structs with arrays, etc., etc. A fully orthogonal type system. We not only have that, you can program in the traditional spreadsheet way. You just do it inside a two-dimensional array of what we call lazy variants, which means lazy because they can have unreduced formulae, which compute, that's what spreadsheet do. Invariant because if you take a spreadsheet, their typing system is like JavaScript, like Python is where I call them the anything goes. They are not statically typed. You can plop a string in a cell, and then 2 minutes later you can plop a number, and the spreadsheet will not complain. We support static and dynamic type system. Okay, here is the link down here. If you can see it, is the link to the presentation, which is much better than this presentation because basically I have like a 50-minute presentation and 40 minutes of that was devoted just to demonstrate the product, okay? The key idea for us to do this is that we forgot about the visual part first. Say, let's define something clean. Let's define a language that can mimic the behavior of spreadsheets or like replicate. Let's find what should be a programming language that has the semantic of spreadsheet computing. That's what I call a language-centric redesign, okay? And then it was born ZenSheet, supports functional abstraction, composable data structure, and there is no entanglement. And again, I say, it truly generates a spreadsheet. 2D arrays can be used as worksheet. The copy and paste works with the translation of the A1 coordinate, etc., including the dollars there. This is the syntax of Lily, the underlying language. You see here the ID. Okay, this is the syntax. I'm not gonna go into formal details. That was the part of the TFP. It came as a surprise, certainly to me, because I'm not smart enough to have seen this on there. But when I started this, I call it an expedition. And I did not expect to survive this long. I arrived at the conclusion just with this idea, let's have a language where the variables can take as value and reduce expressions, but they compute when you use them. So it's a compute by need, right? It's kind of a lazy paradigm, which is why I better say, let's have the lazy type here, but also not have everything lazy, because I wanted a language that could be compiled efficiently, because my dream was, what if we could do a language where I can program with a spreadsheet, etc., but I can only generate efficient code if I want to, okay? Get like within a factor of 5x of C, which I know completely, just in my theoretically possible, just we don't have enough resources to do something that good, but we're actually getting closer. And all ended up, all that was needed, but the implications are deceptively complicated, was take the Strachey model, like we have the L value, the variables, they're boxes, the address in memory, and they have the notion of R value. Now, Strachey never talks about C value, the content of the variable, because the content of the variable is the R value in its model. Those two things are the same. R value of an expression that denotes an L value in C, okay? I'm thinking about people know C, understand what I'm talking. I'm not gonna go into more detail, but the R value of, let's say, A sub I or something, the R value, which is called the value of a variable, is the content of the variable. The CL value here is because the value is what, from the expression, you reach the variable, that's the computation of the L value, and then you take the value, the content of that. So he never needs to say this, which is why, but C value is there in Strachey's model. All that changes is that the R value of an expression is the R value again of the C value of the L value. So this part is the same. The thing is that when we want to use an expression on the right-hand side of the sum, or calling a function, like when we want the value, that's what we do, we compute it. So we take the content, which could be an unreduced expression, like something like X plus Y, and we evaluate it. Notice the semantic of the assignment, I call it reassignment because it's like a changing the value of something. It's actually the same. I thought they were going to be different. This turned out to be a surprise. Okay. Now, how you put a formula there? There is a special form called formula, the formula function that given an expression does not evaluate the expression. It just takes the C value. And when you say takes the C value, mean that the argument to formula needs to have an L value, as is true also in C and C++ or many things. Like every time you want to deal with something that you say, I'm going to take a state in the machine, the memory, then you're dealing with L value. So there is a special function called formula, which allows us to take the content of the variable without evaluating. Where do you need it? For instance, to do copy and paste. Okay. So this is it. A simple change to Strachey's model has incredible implications. Here I have a slide of the evaluation rules. I don't want to go into formal semantics. And believe it or not, if I can show in the meme, this I want to show it in the demo. We support the higher order functions, and you see preferably here, you can see the L values, you can see the formula. This, it's a model which is actually used in like Internet of Things, although it's idealized. But this is what you do many times in Internet of Things. Let's say you have an array of sensors. Here, there. We have 3 arrays of sensors. Each array has 1, 2, 3, 4, 5, 6 sensors. And from that input, we do a mapping. We transform it to some other data, applying some function. Then we apply a filter. And finally, we do the reducing, like we get the sum of each array, the part that passed the filter, or the average, whatever. It sounds familiar, like map, reduce, with the filter in the middle. And you can do these pipelines arbitrarily complicated. You can take the input and start filtering, then apply to map, then filter again, do partial reductions, etc. This is well known to functional programmers. In JavaScript, there are predefined functions with arrays that do the map, the reduce. And yes, there is a map, a filter, and a reduce. There are all of them. ZenSheet, or I should say Lily, now that you know how the sausage is done, you know that ZenSheet is just the IDE, although not trivial to make such an IDE. ZenSheet is just the IDE for Lily. Lily, we support dynamic arrays and tuples and structs, etc., etc. ZenSheet also offers a way to do Monte Carlo. The vision here is to try to make programming kind of like a wide spectrum lingua franca, if you want, without inventing much. It's the very little ego. Literally, the language is the language of Excel with little extensions, and a lot of people use spreadsheets. This is something that is something I have observed. Children in high school, well, not also children by then, boys, girls in high school, but even kids in middle school know how to use spreadsheets. And I used to think, oh, that's why I want to work with spreadsheets, because they are intuitive. Yes, the fact that it's an intuitive interface and people just feel the grid, start putting numbers there and doing and can write an invoice, which is the reason spreadsheets became popular and popularized personal computing, is for the first time, small business owners were able to prepare an invoice quickly. Believe me, I know, because I was there. I saw this happen. Okay, before the IBM PC, people using Epsons, Apple IIs with VisiCalc, all crazy. People were buying computers just to be able to use VisiCalc, and it's documented. Okay, I like to say it because somebody in a paper told me, kind of like a citation either. It's hard to find citations for this thing, although they are on Dan Bricklin's website. He mentions that. But it's a well-known stuff, okay? In one of Bill Gates' biographies, it's also mentioned. So how about we take the language, which is inspiring math, the language of spreadsheets, but made possible to generalize. And now you don't, if you only do an invoice, you don't need functional strategy. But what if you could have those things seamlessly and now create the possibility that you can actually do serious programming with the spreadsheets, with advanced one? a wide spectrum computing. I mean, wide spectrum of users, from beginners to advanced. Have we realized the vision? Hell no. But we certainly make more than one step in that direction already. And now I'm going to talk quickly about the experience report. Because the next question is, okay, but have you proven in any way that this is good for education? No. But we're in the process. Right now, it started in late January, we are running a trial at the university in Latin America. And here is my experience report. The setting. The location is Simón Bolívar University in Venezuela. Not surprisingly, because I studied sociology and statistics in Italy, but then because of a clerical mistake, they took away my citizenship, which forced me to go to Venezuela, but turned out to be good because that university was a top 5 in Latin America at the time, not anymore. And I don't want to get into politics to make it this long. The course is a programming 101 for engineers, but not including the ones that are studying what they call a computing engineering, which is kind of a blend of computer science and software engineers, okay? Software engineering. And nearly all the students have no programming experience. Now, I have been teaching at university for 2 years now. And the reason is somebody ratted me out, telling them they were desperate for professors, that, you know, Enzo's doing research and getting published. Not too bad, but it's true. And at first I don't want to deal with that. And then I realized, wait a second, let me see if there is an avenue for me to have people use it. And I started giving what I used to give there, compiler construction, okay? Languages to languages, the compiler construction specialization. And then I realized, this is not what I need. I need to go to people who are newbies. So the last year I have been teaching programming 101 with another professor. No, the details, the courses just last 1 trimester, but the trimester only has 11 weeks, and there are only 10 usable for theory and 8 usable for lab because I have to spend the first 2 weeks teaching students to use a shell. These are used to visual interface. They don't know how to use a shell. They don't need basic commands, whether it's DOS or Unix. They don't know anything about Git. We need to empower them to have a lab because the university cannot offer a lab anymore, okay? The objectives of the old course are here. They were expected to learn basic C programming with emphasis on array processing and I/O, which makes sense. But this curriculum dates back to my times. It needs to be a refresh. So I propose this. The objective should be that they learn programming concepts, so they are not afraid to learn other programming languages, which aren't necessarily the ones we gave them. But I also will show that they will achieve basic proficiency in at least one, but possibly more. And not to get scared, the people who were like attached to C from the history. This is why I came up with this. They are learning a subset of C anyway. We might as well go with a subset of C++. Because C++ happen to have advantages, and I'm not talking about object-oriented programming, but like a template meta-programming in 8 weeks? Of course not. But constructors, a better type system. The idea that preserve this statically typed language, but much more elegant than C to do certain things, if I JavaScript, because these languages like Python, Ruby, etc., are very popular. So let's also throw a dynamic typing programming language there. But the advantage of JavaScript over Python for me is that the syntax is closer to Java, which indirectly is closer to C. And of course, Lily, because I'm not gonna lie, if I love students, I like teaching, but I have my hands full leading this research and a startup and desperate to get funding. So turns out they are not using Lily yet. But the reason is, again, I don't want to add a further burden to the installation, because to run Lily, you really need to install ZenSheet, which is, remember the model visualization separation is so well separated that the Lily VM is literally a server. And ZenSheet, you run on a web browser as a client. This communicate over a network. So the students need to install a server, install that client. They need to learn about, like, maybe they got some troubles with the permissions, et cetera, et cetera. So I'm using Lily teaching, and they see it. And sometimes they even answer question Lily, because they're like, oh, this is not so difficult. They have the examples. But only next week, probably you're going to have some students installing the REPL and playing with Lily for the first time. The course literally starts with giving them math expressions, and they need to linearize them and compute them. Anyway, from there, we graduate to, okay, remember this? Maybe you say like a equals pi, etc. You can write the expression that tells you whether this is true or false. This is an equation in math. If you see like an assignment, oh, we don't want to go there yet. But the idea is to go from there to a function. The spirit of this formula is that you take the radius, you square it, you multiply by pi, you get the area of the circle. So let area be a function. First syntax that I haven't seen in high school, the arrow function. Let area be a function that takes r and computes pi times r squared. Same thing in Lily with slightly different syntax. This turned out to be not traumatic at all. And from there, very quickly, I could take this one and show them, well, you could abstract that you have 4 inputs here, x1, x2, y1, y2. But conceptually, you're thinking about the distance between 2 points. What's missing there? Have the ability to say, when I talk about a point, I talk about a pair of coordinates. Oh, if I could have that and label those coordinates, the x coordinate, the y1. Turns out you can do it very easily in JavaScript. Here is how you do it. And now you can write the function this and like this. You tell them the dot operation to extract a field of the pair. And in Lily, actually completes a p1.x minus p2.x, there are square, etc., etc. In dynamically typed languages, what about statically typed languages? Here show JavaScript and Lily. Here I'll show you C++ and Lily, because I already told you we have gradual typing. We can do static and we can do dynamic. And the idea is basically to decorate where necessary by indicating types. Coordinate is not a pair of anything goes, string and number. It's a pair of doubles. Array is not a function that takes anything and return anything goes on. No, it's a function that must take a double and return a double. And we talk to them about the benefits of statically typed languages, which are not obvious when you program toy things and little things. The next step, and this happens in week 4, inductive math definitions, the Fibonacci or the factorial, first one, okay, easy. And you see like a factorial of 1 is 1, factorial of n for n greater than 1 is what? Is n multiplied by the factorial of n minus 1. We give them a review of what is a well-founded induction, which it turned out they didn't have that concept from high school, but it's intuitive. We explain induction, we make understand. And of course, we introduce conditional. It's very important, like conditions, because we're going to do recursion. Without a conditional, then we end into infinite recursion. Better do the conditional. The Fibonacci, very easy. Fibonacci takes an n, integer in C++. If n is less than 2, this case 0 and 1, then it's the same n. If not, the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. I'm going to bother, of course, same thing in JavaScript. You don't have to put types. And Lily, we have the dynamically typed version and the statically typed version. Again, banging this idea, because I want them to come out able that when they see a language, and this actually literally given in the lecture of the lab, what you need to ask first is, what are the elements of this course? What are the types? What are the ingredients? Like you're making a recipe. What are the ingredients I have to play with? Okay. Do I have arrays? Do I have tuples? Do I have this? And is it statically typed or dynamically typed? And see that the languages are all pretty quite similar. I'm not going to go over the entire plan. This may have revisions. We are entering a level 3, but look, level 0. computing expressions with the numbers, computing with simple values and tuples. So the part that was giving there the distance and the error circle. Level 1 is when we start doing recursion with induction definition. And for the first time, we show the alternative to recursion, iteration, where for the first time you have a variable I, the index, to traverse an array or a sequence. And you assign I plus 1 in the loop. Red, every time we foray into imperative programming. Level 2, higher order functions. They already have done this. Actually, see here, there is like a computing function reductions over sequences. We give an appetizer in level 1 because JavaScript, as I told you, already implements them. In level 2, they learn to implement higher order functions themselves. They learn they can write the filter function. They learn they can write them a function. And in fact, was part of the exam that they just delivered 2 days ago. Okay. And so we are just entering level 3 now. We have done some of mutable arrays. We still have not done persistence. Pointers and references, have to give them. Okay. And to show the people of the old curriculum that once they learn this concept well, and that's a hypothesis, understanding this will probably be easier. Level 4, never expect to do it because we roughly allocate 2 weeks to each level. As I say, I only have 8 weeks to play with. And that's it. And the results are, so far, students have shown, and when I say have shown means like at least 70% of them have clearly shown this or more. Practical understanding of the difference between dynamically typed and statically typed languages, good grasp of the difference between functional and imperative programming styles, an ability to code in JavaScript and C++. Literally, I feel very good about this. They have done already 2 midterms if you want. And today is the day where they decide whether to withdraw the course or not, and then there's going to be a final. It's just a coincidence that happened to fall today, the withdrawal. And that's why Professor Baral is giving today theory instead of me giving the lab, which I normally do on Fridays. They have already done exams, and most of the assignments include doing the same thing in JavaScript and C++, some doing in one or the other. They have shown at the 3 levels that I mentioned, they have shown proficiency in C, the subset of C++, and the subset of JavaScript we're using. This is the reference. So I'm going to stop here. And I think I have only like 5 minutes for a demo. Unless you want to go over, we started a bit late, but I knew this was going to be a challenge. But at first I want to take some questions that if David is not annoyed by this by now, Dennis already knows some of, Dennis, I don't think I'd say much new that you didn't know about.
Yeah, a lot of this is familiar, Enzo.
Yes. This is the presentation I mentally prepared. and you know, I hope that next year, and I failed to contact you last December, whether we can join forces. I know your areas are kind of different, but I'd like to play into your, we can prepare something very cool, the 2 of us together. Java or something, because I feel like I owe it to you to like kind of like maybe not publish, maybe publish, but to do something together.
Yeah, that'd be fun.
Thank you.
You'll have to watch my the recording of my presentation on legacy software.
I will say I had some technical problems and I wanted to make sure that I was ready for this presentation, but okay, I will see it. It's recorded, right? It's recorded.
Yes, it is. I'll send you a link.
And I actually moved to Boston. I was doing the move, and I have the pamphlet where you told me of the Escape from the Lab workshop, Splash 2017.
That was fun.
I have the document. In fact, finding the document, say, Jesus, I mean, I should really, Dennis and I should do something together someday.
Yeah. We'll do a workshop or a conference paper.
So I probably
do your quick demo here.
Right, so I'm gonna npm run serve my npm run serve. I'm going to show something actually. The model doesn't look very nice, but it's something I'm using to show students who have seen the JavaScript map filter reduce. Here, which I'm calling, not by chance, the HOF light. The one you saw in the picture is the HOF, which I can show immediately after this.
Okay.
And here is because, remember I did that, it was like an array of arrays of sensors, like there were 3 arrays of sensors, 3 of them. So it's an array of 3
And you're
arrays.
getting and you're working with real-time data coming in here.
And I'm working for real time. So here I'm doing the same, but to avoid, because then it's too much abstraction for this. I'm doing with 1 array.
Okay.
And they have already seen. So here is the array of the inputs. It shall not just simulate a random number between 0 and 1.
Yeah.
Here we use the fmap function, which is part of the library. Okay. The fmap function to do a transformation. So take the x, we multiply by 2 and take 1 out. So instead of a number between 0 and 1, now we have a number between -1 and 1. Then we apply a filter that not by coincidence is, please give me only the positive ones.
Yeah.
And where comes positive? Well, positive, it's a function that I must have defined somewhere, what we call a predicate. Positive is a function that takes an x and returns whether x is greater or equal than 0.
Yep,
And we're doing this dynamically type. Var means anything goes. We're doing this dynamically type to reduce cognitive overload the first time. And then I always do that. Then I show how to properly type it if you want to, right? So this is why the array here sometimes turns out empty, or so, but it changes size because depends on how many negative numbers again. Yep. And finally, we have the reduction, which is the sum, another predefined function. Now, it turns out, and I have a model that shows this, you don't need to have mapped as a predefined or filters as a predefined. You can build them in Lily yourself completely, okay? Using recursions and the function abstraction. But this is a nice way to show the model. Now, once they understand that, it's easier for them to understand the non-light version, which I believe you've seen it in years before. Where you see, oh, look at that. It's an array of array. This, what I like this, of course, is because it shows data composition, right? So at least a multi-dimensional array or arrays of arrays. What this really shows is arrays of arrays, because these 3 arrays are independent from each other. And here, so they have nested F maps, because I apply the F map of the F map that goes to each row. And the same for the filter, everything is the F map of the filtering I do to each row. And in the reduce, I have to do the mapping of the sum. So all it boils down to add another layer of F map outside, because I have an array of what I was doing before. What do you think about this, Dennis? Am I just crazy, or this? It's easy? Because I see like it has value in education, because it's not easy for them.
Yeah.
A Professor Krishnamurti, I forgot his name, that was at the TFP in education, told me about a model, actually like a problem that he gives to students. And I was there and I programmed myself, and he calls the waterfall, so-called waterfall, but like Marco Morazan told me properly to call it rainfall, but I called the model waterfall at the time because I didn't realize that that's what he was talking about. And when you see this model, I don't know really what to start. There are a bunch of functions here, predicate for positive, but here's the idea that you have, and I'm gonna stop like this, do one tick at a time, right?
Yeah.
You have this data coming from a sensor, and the rules of the game are, as soon as you see, and you're starting at 0, a -999, that is the marker that the data, it's ended. So in this case, actually, this set of data will be the empty because it ends right away, okay? But if you get something like this, okay, you ignore the negatives, which was the other thing I say, discard negatives, then you have 40, 54, until you reach the -999.
Yeah.
And if the minus, maybe you already knew about this. I learned it literally in January, okay? I literally learned about it. It's such a good exercise, which I haven't given to students yet. I don't think they are quite prepared, but they're getting very close now. So, and he asked us to program in our favorite language. And me, I say, I take my feet to the fire, say, I'm gonna write this in Lily, I have the thing. And the naive version is not difficult. I had the functions implemented already purified, but I implemented my filter function here. Filter the data in query form because it's convenient for this exercise. If it's empty, then the empty array, otherwise, and basically I do the concepts. They're all like this, okay? So I do the tail recursion. This is a function we need to do take elements up to that marker.
Yep.
Yeah. If the data, okay. So I'm not gonna go into the details that this is, if you learn functional programming, it's not difficult to make each one of these building blocks. And then the solution of the exercises, take from the raw data, take up to the end of data, then filter using the protocol positive, and finally take the average of that. And turns out that works. I have a test. And here is the, I can put it out again, reactive, you see, and I can stop it. But this is 21 minus 1, ignore it, 56, 21, and you take the average, you'll be here. Now, what is this other one? So this is, and I click here. Oh, I cannot see the function here. Okay, yeah, because I'm calling it, this is already a tuple. But this uses the waterfall. You see the expression here, it's a waterfall of the waterfall data, and that is the name of this function, waterfall, right?
Yeah.
But I have this other one in my test called FW waterfall quick data, right? And the idea was to show that they're both the same. Well, I'm not gonna lie to you. I did not finish this on time for the exercise. I did the other one. Now, I stayed there during the break. It took me 4 iterations making mistake to do what I was trying to do, because clearly the easy waterfall implies a pass through the data here with recursion to take up to AOD, right? Then a pass to the filter, another pass to the average. Then I wanted to like the clever, like what you see, let's do all this together. The logic, I found the EOD, I stopped there, meanwhile I compute the average, etc. Boy, that was hard. It's the waterfall quick. So I created my own for the done, the add the sum, the add len. And so clearly WF quick, it's called just like the other, takes data, the waterfall quick, but of course WFQ, the helper for, right? Passing 0, 0. And these are clearly what? The sum so far and the length so far. So when we reach the end of the recursion, we tie the recursive knot and we can just, but the logic is so complicated. Again, I blew it 4 times. It took me more than 20 minutes to do. I wish I had come up, but it definitely took me close to half an hour to get this done.
This reminds me so much of what we did in my undergraduate days in programming in Lisp.
Thanks. Yeah. Well, not casually, Marco Morazan, who is the kind of the leader of that conference, right? He's a racket guy. And in a way, he's doing what I'm doing with 2 important differences. One, actually, I would say 3. One, he's teaching students a sit on hall. These people come already with pretty good high school background, okay?
Yeah.
Second, they are computer science students, okay? This is one of the introductory, okay? And I forgot what the third one was. He's taking a functional approach, which is expression first approach to teaching programming. They don't, and in fact, after they learn that, they find they don't like to program in Python. He has proven that empirically. Now, of course, they can program in Python, and actually they tested for that, right? So when they go out to the workforce, it's okay, they are prepared, but they love rackets. All right.
All right.
Okay, thank you.
This is good.
Thank you. Well, let's say we can stop the sharing here.
Yeah.
How do you stop? Okay. Stop. Okay, here is the project.
We have to move on to our last speaker here
Yes,
soon, Enzo.
Thank you. Okay, I was almost on time.
Yeah. Oh, no, you're good.
Is Python still the #1 language for AI? Yes, Python is still the #1 language for ML and AI and expected to do so. And the only reason it's fast enough because all the libraries are written in C, C++.
Okay.
Thank you. Okay.
Thanks, Enzo.
What should I do? Leave or can I stay for the next one?
You can stay for the next one if you like.
Of course. Yeah. Marco.
We have our friend Fred Wilf talking about legal stuff, so this is good.
Oh, I remember Fred Wilf very well.
Oh, yeah.
Great lawyer.
All right, Fred.
So how do we connect this? I'll need some help here.
Okay.